Hello everyone. Good morning, good evening, good afternoon, depending on where you're joining us from. Welcome to Data Platform Geeks webinars. Today is the first webinar of the June series. We'll be having a session on data science for DBAs from speaker Manohar Punna, who's a MVP and Vice President for Data Platform Geeks. Data Platform Geeks is the community event team of eDominer Systems. We also have SQLMaestros from eDominer, which arranges masterclasses, HOLs, and other events. We have Peopleware India, which is the corporate training part of eDominer Systems. As you may already know, we are organizing a data platform summit in August, which will be held at Hotel Radisson Blu. It features 3-day learning events on data and analytics and 2 full-day training pre-conference training events. A session list of 54 sessions has been announced. Part 2 of the session list will be released in the next week. Data Platform Summit features more than 100 sessions from global speakers from 15 plus countries. We have Microsoft Redmond experts and MCMs and MVPs joining us for Data Platform Summit. This is the DPG core team, which plays a very important part in organizing all the events. These are the eDominer teams across India, which play the backend support for all our community events. Special thanks to Microsoft for their help with all our events that we are organizing. As you may already know, since you are a part of Data Platform Geeks community, we organize special events for learning and training professionals in data and analytics. If you have any questions, please join the Facebook group and you can post them during or after the webinar. Over to the speaker now.
Thank you, Trisha. Let me share my screen. All right, I would like to quickly make sure that everyone is able to see my screen. Please do say yes or no in the chat window. If I see few responses, I'll continue and be sure that I'm not talking to myself. Awesome. So I've got 2 responses. That's good. I hope everyone is able to listen to me. Alrighty. Awesome. All right. So today I'll be giving the session on data science for DBA, how to get started. So this session will mainly concentrate on, we'll not dive deep into data science, but we will start on the basics and show what options are available to start with data science. Being a Microsoft data professional, you know, it's important for us to take this step right from the current role that we are playing as a DBA or a database developer and move slowly towards being a data scientist. A quick word about myself. I am a blogger, speaker, and mentor, and I'm a data platform MVP, Microsoft Data Platform MVP. I work as a data platform consultant for Lobsterpot Solutions based out of Melbourne in Australia. You would have already visited my profile, so there are a lot of blogs on SQLServerGeeks.com. Currently Data Platform Geeks, but you will still be able to browse the blogs on SQLServerGeeks.com. I'm a regular speaker at different events, but the most important thing on this current slide is my Twitter handle. So you can actually follow me and ask questions, and I'll be able to help you in whatever way feasible. So today's topic, I'll be covering a bit about advanced analytics, try to explain not in detail, but very briefly what advanced analytics mean. Then I'll quickly jump into what data science team means. So data scientist, even though we are called as data scientists, it's actually a team process rather than a single person doing end-to-end everything. So we will understand how that fits into different roles as part of a data science team. we'll see R instead of R inside SQL Server, which is introduced in SQL Server 2016. Uh, and also we'll be jumping from SQL Server into RStudio, and we will see how we can use RStudio, a simple but very powerful tool. And then we'll try to build a model in Azure Machine Learning Studio, deploy it as a web service, and consume it in RStudio as well as inside Power BI with the power of R. So I'll not be diverging more with R and Python. So this session will be covering mostly on R, but as a stepping stone, you can choose. They are similar, they have different functionalities, but in this session, we will be talking more about R. So what is advanced analytics? By the way, when you, if in the session, if you have any questions, please do use Q&A panel to ask your questions, and at the end or in between, I'll take a break to answer your questions. So coming back to the session, advanced analytics. So if you see this picture on the screen, this image has some information about how analytics has changed its meaning over a period of time. So 10 or 15 years back, when someone says analytics, it's more about pulling the data, making connections in your Excel sheet, and then trying to build pivot tables and different charts. And that would have given you an overview of reports inside an Excel sheet. So this was pretty much analytics that you can perform, which will tell you a story about what was happening in your organization, depending on the data that you're collecting. But when it comes to diagnostics, where you started building reporting services reports, which you have some triggers or filters that you can apply, and started to drill down and explore the data by building analysis services models, and you are able to import that model in Excel server, Excel sheets, and then try to expand by date and drill down deep into your data, where you are able to perform some diagnostics. If your sales were not up to the mark, why did that happen? Was there any issues that created that? So you were able to do that like 10 years back, and that was advanced analytics at that point of time. But slowly it started to change, and you started seeing data mining, where you were able to predict based on the history of data that you have. You were able to predict by using some algorithms, and you you were able to predict what will happen in near future. But that was not strong enough to actually make a decision. Slowly it evolved, and we started with this term of data science. If you see the description at the bottom, data scientists are not business analysts. They are professionals with the capability to derive mathematical models from data to reap clear and hard-hitting business benefits. So when I was talking about how the advanced analytics evolved from being descriptive and diagnostic and then predictive, but slowly it is moving towards how based on your data, what is the decision that you need to take. It is able to prescribe that and also take that decision and implement the action also. In case of fraud detection and those kind of things, where in banks it will be really late when an employee is given a decision and then he needs to take the decision and block a transaction. So it is important in those scenarios where decision is made and the transaction is blocked immediately, right? So depending on the impact, these scenarios change over time. So a data scientist is not a business analyst. He just doesn't understand business requirements and pass it on to the technologist to build a solution for solving a business problem. It's more about understanding what will help the business based on the data that the business already have, and then analyze the data and build something and predict something that will help the business grow. So it covers more than just a basic business analyst. So the requirements are like they need to network well across different business units. So they just don't talk with business business people or the technologists, they actually need to involve and try to define and uh, find different solutions based on the data and the analytics that they can run over the data to find those solutions. So this is where we are moving. So as a data science team, what it takes to be to build a data science team, what all needs to be included in the team process. They need to have a strong business understanding. They should be able to define objectives and also identify the data sources that will help them solve this business need, right? So they need to work with business, because the business can say, I need to understand where my sales are going to be next year, or how to improve the sales next year, but they don't understand what can be achieved with the data that they already possess. You know, it instead of increasing the sales next year, they can actually increase the sales in the current year itself, day by day, hour by hour, right? So the data scientists actually help the business to understand those objectives as well, because they know the possibilities of what can be achieved with the data they currently have. When we talk about data sources can be very, very widespread. If you talk about companies where they are using different vendor products, they may have object models, data stored somewhere. They have Excel sheets some teams are maintaining. So it is important to understand where the data exactly lies, and you should be able to get that data over into a single source which you can use in further analysis. Modeling is where you actually create the algorithms and train the models with the data that you have. This modeling is not what you see in your analysis services models. I'm not talking about the analysis services cubes or the multidimensional models. We are talking about the algorithms, which help, which are trained based on the data that is provided. And you may not be a core data scientist writing these algorithms, because most of these algorithms are already designed and available in the market in different options, like different tools provide these options. So you can use those existing models, but you need to understand how these models work to choose the right model. I have a slide later in this presentation which gives an overview, which is like a cheat sheet that you can use depending on the decision, depending on the data that you have and the decision that you need to make. You can choose a corresponding model. And once you train the models, it's important to operationalize it. You should be able to use that model to make some predictions. And once you are able to do that, end of the day, if you don't meet the business objectives that you define in the first step, the whole process is just not feasible, right? So you need to always retrain, rescore. The first attempt may not be successful, but it should be close enough to achieve the business object in a very short or a bit long term, which is acceptable to the business. So this whole process cannot be done by one single person in a company. So it needs a team that needs to work through all these steps to to be a fruitful data science team. So I have broadly divided this for easier understanding into two roles. So the first one is machine learning engineer. You know, he is the one who is a deep mathematical person who understands how these algorithms work. He should be able to choose different models, and he understands R and Python programming. And also, if you want to take data science to a next level, which is like a deeper neural networks analysis or deeper learning, these are the engineers who actually can do that. The AI professionals who are able to create models and generate predictions that helps the businesses run. And when we talk about data engineer, even though they can build the model and they can do the predictions, it's important to have the right data set for them to achieve their goals, right? If you don't have the right data, right history of data, no matter how critical algorithms or how complicated algorithms you use, without the right data or without the right history, it's hard to get to accurate predictions. It will not be 100% accurate at any point. You will be able to reach close to the accuracy. It's like probability. When you are in school, you would have been taught about probability. A simple example would be if you go to a casino and then you start playing dice. Not even casino, you can just talk about two friends playing dice game. A chance of getting six on a six faced dice is 1/6. Like in one in a six times, there are six options in which out of six there is only one option where you can get a six on a dice. So that doesn't mean that when you throw the dice six times, in all those six attempts you will get at least 1/6, right? It means that every throw of the dice has a possibility of 1/6 to get a six on the dice roll. So if you see six times, it will actually reduce the probability of getting a six because the chances increase 1/6 into 1/6 multiplied by 1/6. So it's 1/6 to the power of 6, right? So that means that you may or may not get a six in the six attempts. So you will be able to predict like the chances are increasing or decreasing, but you will not be able to say 100% that in this chance you will be able to get a six. So over a period of time, depending on the number of attempts that you make, on an average, the accuracy will be close to 99, close to 100%. I would say 99.9%. So that is how probability works. That is how predictions work. It doesn't mean that every time you predict, you are going to get 100% results, even with data science or AI or machine learning, right? So as a data engineer, you need to provide the data in the right structure, whether it's structured data or unstructured data, whether it's big data or NoSQL or SQL Server. So you should be able to work with different kinds of data that is available. You will be doing more of a data stuff, like you will be cleansing, you will be maintaining the data quality, you'll be preparing the data in the right, getting it in the right format, so that that can be used as input for the model, which will help the data science engineers to use this data and make that model more useful. So R and Python are the current most popular data science languages existing at this point of time. There are also some other languages, but widely used languages are R and Python. Python is picking up slowly. There are few features which are not available in Python, and there are few features which are not available in R. This is a very extensive list, and R has got like some thousands of packages that are available on a site where you can actually download these packages, which is open source. So R and Python both are open source. So you will be able to download these packages and use them directly in your applications. R is built as a research a research project at statistics department at University of Auckland, and it helps in data manipulation as well, not just creating the models and training the models, but also doing some data manipulations, and also the end user friendly graphical displays that are available. So we will see this in the R Studio as well as in Power BI when we are using R. In SQL Server 2016, R was introduced into SQL Server, so you were able to run R scripts inside SQL Server itself. Because all the data manipulations is much easier in SQL Server, because SQL Server database engine is a database product, software, and it understands data, so it can do parallelism, it can do sorts much more efficiently when compared to other programming languages. So you can do all the data manipulations inside SQL Server, and at the end, when you actually need the data to be used as an input to your model, you can write that script in SQL Server itself. Even though the engine is separate, it can run R scripts inside SQL Server. You don't need another development environment to run your R scripts. So that's the main idea behind introducing R into SQL Server. And Python is now supported in SQL Server 2017. So let's start by seeing how R is used inside SQL Server. So external scripts enabled is a new configuration parameter that needs to be enabled, which will help you to run an external script. So they didn't made it as a hard-coded thing for R. They actually made it dynamic so that that helped them to run Python now in SQL Server. They may, when I say they, it's Microsoft. So Microsoft may in future try and add capability of running other programming languages inside SQL Server. Although this is, SQL Server Management Studio is not an development environment, but most of the DBAs and database developers, not even database developers, but most of the DBAs are used to using SQL Server Management Studio. And giving this capability inside SQL Server helps them explore and step into other programming languages by using SQL Server Management Studio. So by enabling this configuration parameter, you will be able to run external scripts. So I've got a database where I've got a very simple table, which is a key and the return value. So based on this key value, a value will be returned, right? I'm not taking very complex data structures here because the whole essence is actually understanding how these scripts work rather than trying to build a complex demo with high data volume inside it. So what I want to do is, based on this data, build a model and then take the values which I am passing in this table called as predicted values and try to predict a return value based on the values that I'm passing. The predictions will not be exactly what it is in this table, but it will be based on the variance, the standard deviation that is applicable for the return values here. If you see like first 1, 2, 3, the values, even though it's 1 and 3, the value written for 2 is not 2, it's actually 1.5. So there is some variance in the way the values are written. So for 4 it's 5.7, but 5 it's 5, right? So it's not sequentially increasing, it's not a standard increment between the values, between the intervals. So it depends on, so a complex calculation needs to be done behind the scenes to be able to predict what value will be written based on the data key that is passed in. And this gets spread the standard based on the standard deviation and the median values. This gets spread across the data that is available for analyzing the model or for building the model. So when I pass in the predicted values, when I pass in the key values to predict some return value, it will be based on that algorithm, the trained model. So the procedure that we use to run an external script is sp execute external script, and you specify the language. So when you're writing a Python script, you say Python, but when you're running an R language, you'll call R. So you can see how dynamic it is. You can actually, when Microsoft adds support for more programming languages, maybe you can run JavaScript or any other language in future once Microsoft adds the functionality into SQL Server. And this is the very simple 3-line script which actually creates a model. So the formula is very simple. It actually calculates the return value based on the data key, right? And we are telling work out this formula based on this data, linear model data, right? And once you get that, you serialize it and save it into model bin, right? And the payload, right, is from the model bin, put it into an output data set, right? So output data set is basically for us to view the model. There is no point in viewing the model because it will be a var binary string. So you'll not be able to make any sense out of it. But internally, that is the model, and it's saved as a var binary, and we are displaying it. So once the model is generated, so linear model data, the input, you specify the model input data here. So it is a straightforward input, which is select string which selects the data from the linear model data, right? And you are giving it a name as linear model data, and that is the data that you specify here. So it should be the same name that you specify in your command. And once you generate the model, what you want to do is actually predict the values based on the model that is generated. So you get the linear model into the current model, and then create a new data frame for predicted values, and that will predict a return value based on the current model. So rxpredict is a function, and you are returning that predicted value based on the input that you're passing in, right? And when you see input, that is based on the predicted values, which is nothing but the select data key. So the values that we are going to insert into this table, based on these values, you will be able to return the return value. Okay, this is the prediction that is made by the linear model that we just created in the previous step. And once that value is returned, what we are trying to do is put that new key that we are passing in and the predicted value that is written by the model and just display it as a result set. So let's go ahead and insert our sample data for which the value will be predicted, and then run this two commands. First step is creating the model, which is trained based on the linear model data set, and then we predict the output for the predicted values that we are passing in. So in our data set, we had a return value for 1 as 1, but here it is predicting it as 2. That's because of the way the data is spread across, right? So these will not be accurate because your data is not evenly distributed, right? So it's always some values are higher, some values are lower. So based on how the pattern is, this will predict the value for the key that we are passing in. And the model that we were displaying, it's a var binary. So we will not be able to read this, but internally it is stored as a var binary string, right? So this is to actually show the power of, we created a model, we passed some values and predicted some values. This was not possible within SQL Server before. So you are able to do this because we got the power of R inside SQL Server and will be able to execute R scripts inside SQL Server. So RStudio is a development environment for R. So this is an open source project which helps deliver R for the open source cause, of course, but it supports direct code execution. It looks and feels like sometimes I feel like running PowerShell IDE, right? So it's similar to that, but there are more options and more screens that you need to understand when you're using RStudio. So I'll quickly introduce you to this development environment where we will see how to create a model, predict the values, but also how to create the visuals from the predictions that we have created. Right. So let's quickly jump to our RStudio. So when you see in PowerShell, you will be able to understand that you can write your script here, not the PowerShell admin prompt, but it's a PowerShell ISE. So the RStudio IDE helps you write your queries, the R code here, and the console is at the bottom. So even though you write your queries here, whatever commands you select and execute will be run in the console at the bottom, right? And you will be able to see all the environment variables that you create here. And any history of the commands that you run will be shown here, and the connections that you make are shown here. And there is also this pane where if you import any files, you will be able to see that here, right? You will be able to explore the files here. And once you try to plot some data graphs, the visuals are shown in the plots area, and any packages that you import are shown here, right? And also the help is integrated and the viewer, right? So these are different screens that quickly help us understand better about RStudio. So in this example, I'll be using the RODBC package. So this is when I say library RODBC, it will actually, if the package is already installed, it will use it. Otherwise, it will connect to connect and install the package in RStudio. So RODBC is used to make connections to SQL Server or ODBC connections. Model R is the package which has some models that we can use. And ggplot2 is a very popular package which is used for creating amazing visuals inside R. So let's import these three libraries. And so I have got an ODBC connection to my local SQL Server. So if I open my ODBC data sources, I can quickly show you. All right, so that got. So I've got SQL 16, which is nothing but a connection to my SQL Server using the SQL Server native client driver to my local instance, right? So I will make a connection and store it in a string or in a variable con. So once I do that, you will be able to see under global environments, I got con, which is actually saving my connection for ODBC, right? And I'll quickly run a query called which is saved in my RStudio data, right? And I'll quickly run this. So when I run a SQL query by using that connection and pass the query, it will actually get the data. I can actually visualize this data. So I can say view. View is a function which will help me view the data. So you will pass in a parameter, or similar to what you do in partial, you actually select a variable and pass it through to the next command, right? By using pipe operators, right? So by using this kind of pipe operators, right? So in similar to pipe operators in R, we have something like this percentile greater than symbol and percentile, which is like a pipe operator. So I select the variable data and then pass it as a parameter to my view function. So it has a similar effect of running a view data. So instead of running multiple lines of commands, you can actually run that in a single. So you can see the data in a grid format, right? But the same thing can be achieved by running a pipe function, by passing the variable by using pipe to my next command, which is view, right? So quick tip there, but you can write multiple commands in the single line by using the pipe. And we'll create a linear regression model. So LM actually is a function to create a linear regression model. What we are predicting is the rate. So if you see the data set, we have got color, length, width, and a rate, right? So based on the value that we pass for all these three parameters, we want to predict the rate. So this is the sample data. So what we are telling is like predict the rate based on the color, the length, and the width that we are passing in, right? And when you say summary model, that will actually create and train the model. So when I run this, you'll see a lot of information that is written into the console window here. So you see that is the formula, the call, right? And you see the residuals. And most importantly, what you need to understand is coefficients. Coefficients is the values that is used for predictions. It's like estimates, right? So it says this is the estimate and this is the standard deviation, and the values that will be used for your predictions, right? So how the formula works is you actually have an intercept, and based on the values that you pass, this is the weightage of each value. I can say it's a weightage, but it's actually a coefficient. Like when you pass 1, it will it's a factor of 1 into this value, right? So that's how these predictions work. So we'll see this in detail, but it's important to understand these kind of calculations when you're talking about machine learning and using the models and training the models. And if you see here, multiple R square, it says 0.9927. you can look at this as the accuracy at which these values can be predicted, right? So that's what the multiple R squared means. So there is a package called Broom, which is useful for looking at, which helps you look at the data in a more cleaner manner, right? So the model that we just created, even though it's displaying the outputs as, multiple lines with different data sets in here, coefficients, residuals, I'll pass it on to Broom, and the tidy function is the one which will display it in a very readable format. So you'll see term. It's actually displaying in a table format. So what is the p-value? What is the statistic? Right? So you will be able to see this by using Broom package. These are small tips, but it doesn't make a difference with the model. So what now we are trying to do is, based on the data that we are passing in, we add predictions for model, right? And then plot it by using ggplot and show it as a density, right? So these are the different functions that help you plot the graphs. So when we run this function, you'll be able to clearly see what I mean. So this is the distribution of the data, right? So this, based on this graph, the values that we pass, it will be able to predict what value will be selected and what value will be predicted, right? So if I pass in, pink, so I'm not passing in blue, but I'm passing in pink value, not 0 for teal, and the length is 5 and the width is 1.9. So if you see the data, I am actually passing in the row number 4, pink, the length is 5 and the width is 1.9, and the rate is 0.4, but we'll see what our model will predict with these values. How do you calculate that? It's really important to understand that. So when I pass in, this is the intercept. If you see the value here, minus 0.14758 is my intercept, plus the weightage of each value that I'm passing in. Pink, for pink, it's minus 0.49083, right? So this is a rounded off value of 5 to 5-digit decimal after decimal, and the value that I'm passing in is 1. So that's like a factor of weightage of pink. And then teal is 0, so I just multiplied by 0. And then length is 5, so it's 5 times that value that it is estimating. And then it's 1.9, so that's the value it is estimating for the width. So when I run that, so this is the value that the model will predict, right? Because it has already calculated these estimates. So this is the job of the model. When I train my model with the data that I'm passing in, this is the job that it has performed. It has got the estimates for each value based on which the output will be predicted. So when I pass in these values, you can see that this is the value that it will be predicted. So this actually explains how the model works behind the scenes. So if you understand in this demo, we have actually seen how we can explore the data. We understood different parts of RStudio and how we are able to plot the graphs inside uh, inside RStudio, right? So let's jump to the slide deck. All right. So the similar thing, instead of doing a lot of coding in R, we are always GUI friendly. I mean, as DBS, we have started learning by using the Management Studio, Object Explorer, and we hate coding to some extent. But with machine learning, it's important to understand the power of coding. But even though we don't like coding, there are some tools like the Azure Machine Learning Studio, which will help us without writing a single code. I'll be able to use a model, train the model with the data, and then predict the values based on the data that I'm passing. Once the model is trained, I'll be able to score it uh, with some values that I'll pass and make the predictions. So Azure ML Studio is a Microsoft service which is hosted on cloud. So you don't need any resources locally to run Azure ML Machine Learning Studio. It will help you in building and deploying the model, and also within share this. I mean, you will be able to deploy it as a web service, and you can consume it through different tools that are available. It's very easy to learn because it's GUI. So I've put in a screenshot here which will explain where you can go to start with different steps of machine learning. When you are new to machine learning, there are very good links to how to start with machine learning, and there are also steps to how to start with when you're already an R and Python user, how to start with SQL Server, Azure, or Azure Machine Learning Studio. So the next demo is how to use the Azure ML Studio. We'll actually create a model, deploy it, and then publish it and consume it in our studio as well as Power BI. So in Azure ML Studio, once we log in, we'll be seeing this landing page, right? So once we are in the landing page, we can go to our experiments, right? So what we'll start with is by adding a data set. So we will need some data to work with first. So let's add some data set. At the bottom, you'll see new, where you can click and select data. But there are a lot of sample data sets available on Azure ML, but we will use a CSV file that we already have. This is again a very simple data set, but what we will do is use this data set to train a model and then consume it as a web service. So once we have the data set, we will start by creating an experiment. So let's start with a blank experiment, and you can see it looks similar to your SSIS, where you can drag and drop different components onto your workspace. So there are a lot of sample data sets, as I've said, but we will use our current data set that we have. So we'll drag and drop the data set. Once we have the data set, what we need is we need to split this data so that we can train with some part of the data and then use the rest of the data to score our model. So let's go to data transformations, where we have split data, right? So we pass it on, and then in the split data, let's say we want to use 70% of our data to train the model, right? And then we'll use the 30% of the data set to score the model and make sure that, I mean, just see how good the model is. So what we need after that is actually a linear regression model, right? So this is the model that we'll use. We need to train the model, and that's here. So when you drop in train model, it says the first input is the untrained model, which is our linear model, which is still not trained. So we'll use that. And then we need some data. So first data set is actually the 70% data set that we are getting from here, fraction of data in the first data set. So we'll use that 70% of the data to train the model. And then once we train the model, um, it it needs what columns should be predicted based on the model that we are training in, right? So we'll include the value which is to be predicted based on the key value that is passed, right? So after we train the model, we need to score the model. So the trained model, so if you see here, it says train model. So the output of a train model task is a train model, and then we score it with the rest of the data set that we have. So once we have this, we will save this. Let's call it DS for DBA experiment. Save this and then run it. So once we run, we will be able to. So this actually runs and validates all the tasks that we have created here. Once that is validated, once that is run, we will be able to set up a predictive web service. So retaining web service and predictive web services are different. So when you create a predictive experiment, what it does is actually creates a trained model, right? Which is trained based on the training experiment that we have run. So whenever you have more data to test, like in continuously in a production environment, what you do is you continuously train your model and then rescore it, and then keep on updating your predictive experiment, right? So you have got a web service input added now and a web service output. So you can consume this based on the trained model that you have. You can pass in a sample value by using a web request, and then it will score based on this trained model. It will score the value based on the input that you're passing and then predict an output, right? So we'll run this, and then it enables the option of once this is run, it enables an option of deploying the deploying web service. So we have the model which is trained and which can be used for predicting values. So we will deploy it as a web service. So till now I have not written a single line of code, right? So it's very straightforward. So it gives me an API key that will let me authenticate to the HTTP request that I can raise. And when on this screen, you can click on the API help page. So we'll go with the request response model, like request response, in which you can actually do a HTTP post request and get request, right? So when you post data, it will actually return a predicted value. We are not, I mean, I'm not sure how many developers have joined this session today, but I am not a developer. So I've learned a few tips when I'm doing this. So in the sample code, it actually gives you the whole code to help you pass in a value and get an output. So the list values is where you actually pass the value, and then you get the response out, and then it prints the output in the form of JSON result, right? So all the code in R is actually provided here. So once you have this code, it's easier to go through this and see what's happening. It actually uses R curl package, which will help you do the post request, and R JSON package, which will help you, make and break JSON datasets. So this is just getting the text gatherer and header that you need to pass to the post request. It gives you an option to replace the API key, which we just copied from the previous page here. We copied the API key here. And it makes a curl perform, which is a post type request. And then if it also has the error handling code in it. If you get a response which is an error, it will throw an error. So you get all the code straight away that you can use inside RStudio. So let's take this code and put it in our RStudio, right? All we need to do is change the API key that we just copied, and then we replace the HTTP URL. So it's just the same code that I'm using. I'm just going to replace the URL and the API key that I just copied from here. So I'll be passing in a couple of values like 17 and 20 here, and want the predictions out from these values, right? So let's import the libraries. That should be fine. Oh, that's from the previous ODBC connection. Fine. So I'll just make all of this run in a single go till this part where I'm actually printing the result set that I got in the JSON format. So you can see the messages where it says, it's actually making the connections, it's successful trying to connect and it's connected. So you can go through this log. But what is important is like it actually gives me the output in the form of JSON, and then it displays for 17 it has returned a value of 17.24, predicted a value of 17.24, and 20 it has predicted a value of 20.234. So this is, it's not getting trained right now. So I have trained the model with the data that I previously provided, which I uploaded, and then it is using that trained model to predict these values based on the input that I'm passing. So imagine this in your production environment where you actually predict these values on the go because you have already trained your model with the previous data that you have, right? So you can have this displayed onto your Power BI as well. So what we do here is I'll save that JSON data set into a variable, right? And then get that into a data frame. And when I get that in, I'll import the ggplot, ggplot2 package, which will help me design beautiful plots, right? So when I do this, I am actually plotting the values that I got into a graph here, right? So x-axis is the value that I'm passing in, and v3 is the value that I got back from the model. So you can have these kind of graphs in Power BI that will show you whatever values are passing in and whatever values the web service is returning, predicting based on the model that you have trained before. How do I use this inside Power BI? I've still got 4 minutes, so I'll try to finish this and then take questions later on. We'll extend some time for the webinar, maybe five minutes more. So let me quickly open the Power BI desktop. So the best thing with Power BI is in Power BI, there is a visual called R. What it does is it will enable you to write R script inside Power BI. So it is really straightforward. Wow. I don't know what happened. It just is black. I can't share my screen. I'll relaunch the Power BI desktop because I'm not sure what happened. It actually is just a black screen. I hope it's not with the sharing. I'll quickly unshare my screen quickly just to make sure that it's not the share which is creating the problem. How do I stop sharing? Yep, stop share. Wow. It's some problem with my Power BI desktop. So that's Power BI trying to open up. It just comes up with a black screen. It's weird. All right, I'll try and do it the other way. Let me quickly go to powerbi.com. I hope this demo actually works because it's really interesting to see the visuals in Power BI. You know, the way most of the visuals nowadays are built in Power BI. So, or it makes it all the way more powerful when you start using Power BI. So let's go here. Let's go to report and try to create a new report. Yeah, any data set, doesn't really matter. So I have CNR visual here. Great. I'll try one last time to do it with Power BI desktop. So meanwhile, if you have any questions, please do start posting on the Q&A panel, and I'll try to answer as many as possible. If I'm not able to answer everything, I should be able to, you can post the questions further on the Facebook group that Satya shared earlier, that Trisha has talked about earlier. See, I can see the data, I can see the model, but I can't see the reports. So there is some issue with the Power BI desktop, which never happened before on my system. So, yeah, my page. So sorry, I was not sharing the screen, but you can see, I can see the data, I can see the model, but I can't see the report page. I'm not sure if this is something to do with the screen share that I am doing currently. It could be, maybe it's screen recording that's blocking Power BI desktop. I've never faced this problem before. So there is an R visual that you can import, and by just copy pasting all this code, because we are plotting this graph by using ggplot2, you can actually get the same visual inside Power BI. Unfortunately, I'm not able to show this today because of the Power BI desktop issue, but what you can do is actually copy paste all of this code. By selecting the R visual, what happens is it will open an R script window at the bottom of the screen, and you can just copy paste all of this code, which behind the scenes use R to run all this code and then displays the plot that you just generate here. Right, so I have some questions. Instead of R language, can we use the C# language? We can, but that is only for consuming the web service, right? So R language helps you actually do the modeling and train the model and all that. But once you train the model and publish it as a web app, web service, what you can do is like you have the sample code here for consuming this service by using C#. So what you do is you pass this, and it's similar to making any API, any post HTTP request call, right? So it is basically an HTTP API that is provided. So what you'll just copy paste the API key into this code here, and then pass in the input values that you want to pass, and you get output as a JSON string which has predicted values in response, right? So you can use C# to consume the web service, but not um, to actually create the model and um, train the model, right? So R and Python are more of a data science languages. C# is more of a development language. I'm not sure if they have any packages, any APIs that you can use, but right now I am not aware of that. Okay, next question again from Sriram. Create the models always we need to use R, Python. Not exactly. There are other programming languages as well, and without writing a single line of code, I was able to create a model and train it and then publish it. This is all through GUI. I have not written a single line of R code in this experiment, right? So it's not a compulsion. If you want to do something which doesn't exist already, there are a lot of models available, and I'll just quickly jump to my slide deck quickly so that I can show you this cheat sheet that I was talking about. So there are different algorithms that you can use for different type of predictions, right? So all we were trying is like fast training linear model, where you have a key value pair, you pass a key, and based on that, or a set of keys that you pass, and then you predict a value, which is a linear regression model that we were using. But there are other many other models that you can use for different types of predictions and different types of data that you have, right? So this cheat sheet and links are available in the demo that I'll pass in the slide deck that I'll upload. The next question that I have is, can we call R code in SSRS? We in SSRS, I'm not sure if we have the I don't think we can call R code directly in SSRS, but in SSRS we can actually I'm just trying to understand the need or places where you can actually use R code inside SSRS. Because SSRS reports are more static reports, they are not interactive. But when you use SQL Server 2017 Enterprise Edition with SSRS, you can actually deploy Power BI reports as well. You can actually use Power BI reports as well inside SSRS. So you can use R code that comes with Power BI inside your SSRS. But SSRS as such directly will not be able to directly run the R code at this point of time. I'm not sure if that changes with SQL Server 2017, because I have really not used SQL Server 2017 SSRS. So to answer your question, I exactly don't know, but I think it is still not possible. But you can write scripts to run R, like you can write stored procedures inside SQL Server to run R script, and you can call that stored procedure in SSRS, right, as a data set. So that is an alternate way of running R script that you can use, that you can consume in SSRS reports. Hope that helps. All right. That brings to an end, and I would quickly like to walk you through a couple of slides about the Data Platform Summit pre-conference that are available. The Data Platform Summit has been announced that is happening in August, and we have like 12 pre-conference sessions that are happening during this conference. it's really wonderful because we were able to secure very popular speakers this year. Um, so we have Dmitry Korotkovich, who is a Microsoft Certified Master and MVP from US, who will be doing a troubleshoot and optimize SQL Server like a pro, a full day training. And we have Sunil Agarwal, who has been a very popular speaker, and you all know him. So he'll be doing how to migrate your on-premise databases to Azure SQL DB and managed instance. We have Rezarad, who is a very popular BI expert. He'll be doing a Power BI from rookie to rockstar. Dr. Leila Etati, she is a data scientist and also a AI MVP from New Zealand. She'll be doing two pre-conference, one on the leading edge data science with Microsoft tools. So this will be a very important full day training to start with data science with using Microsoft tools, and she has a second pre-con on the next day. We have Andy Leonard, a world-renowned SSIS expert. He'll be doing SSIS and Azure Data Factory full day training. Cosmos DB, if you're really serious about Cosmos DB, Madan Gajendran and his team, actually it's not just Madan Gajendran, but his team from Microsoft will be delivering a full day training on Cosmos DB. The second pre-con is in continuation and actually an advanced level. We're building intelligent applications using Microsoft AI platform by Dr. Leila Atadi again. So we have Steph Flocky, who is an expert in R and data scientist. So she'll be doing practical R for everyone. Sanjay Mishra and his team, the Azure Cat team, Data Cat team actually, will be doing how to build a scalable data architecture in Azure. We have Joey and Denny coming back again. So Joey will be doing a full day training on Linux for SQL Server DBAs. Peter Myers, who has been a very popular speaker last year, will be doing a full day training on zero to analysis services. And Denny again will be doing a full day training on high availability and disaster recovery, both SQL Server and Azure. So please do visit dps10.com and also join our Facebook and LinkedIn groups to post your questions, and you can also answer some questions there. You can also contact us at contact@dps10.com if you need any help with registering to one of the pre-cons or the conference itself, and you can reach out to the numbers that are provided here. All these slide decks will be uploaded. So thank you for your time today and attending the webinar, and we have more webinars lined up this month. So please do join the webinars and enjoy your day. Thank you, everyone.